Hi there, I'm Nate Lampton, and I'm going to be showing you guys the paperwork and all of the completed work that's necessary to do a solar installation by a homeowner such as myself. So we'll start going through all of this paperwork. Okay, well, first of all, we've got the main application form, and I live in the city of Oakland, California. And they have a specific process for doing PV installs or any kind of solar installs. And so they provided this paperwork that specifies everything you need explicitly, just saying, define what it is you're going to install. And then you have to submit to the city site plans, a roof plan, photos, framing details. So this is like what kind of structure, the 2x4s that are in your roof, rafters, that sort of thing. They also were very picky about what size bolts I was going to use, the fasteners. Structural plans. This includes doing some calculations on the amount of weight that you're going to be adding to your roof. And then they go into some details here about what kind of racking system you're going to use. Ultimately, they want to know how many pounds per square foot you're going to be putting on your roof. Just making sure that you are up to certain standards, and then a couple of check boxes, and then you sign down at the bottom. Also, as a owner builder, if you're doing this work yourself, the city of Oakland requires that you just sign off on all of these things, basically saying that you're accepting all liability. If something goes wrong, it's your own fault. If someone gets hurt, it's your you have to cover them, all of that sort of stuff. So that's all just your standard liability cross-off for if you're doing any work yourself in the city of Oakland. You have to do this for every permit in Oakland if you're doing work yourself. So let's go through these pieces then. So first one is site plans. And so this is a big 18 by 24 printout. When the inspector comes, they have said that if this is not posted publicly outside near the area of work, the inspector will just leave. So you have to print it out, at least in Oakland, you have to print it out on a big piece of paper like this, and you have to post it outside. I brought them indoors just so I can go over them with you guys. So this first one is site plans. So site plan really just means a map of the overall area. They also specifically say to take an aerial photo, so you can take this off of Google Maps. And then they say they want to outline your property with white dashes. So there you go. This is aerial view. This is an overview of the house. What I did to make this drawing here, and actually all drawings I used LibreOffice Draw. It's free software that you can use for this purpose, and it worked much better than any online tool I could find, and it was great for handling these like large photos plus drawing layouts. What I did for this image though is I just took this picture, this aerial photo, and I inserted it into LibreOffice Draw. And then I just traced the outline of the house and the driveway and my garage, and then turned it into a labeled drawing, which worked pretty well. It also might be worth going over, what everything is that we're doing in general. So we've got 16 solar panels that are sun power panels that I got off of Santan Solar. They're a great secondhand solar provider. The inverters, I'm using microinverters for this project. These are in-phase inverters. A combiner that combines the two sides of the roof. So there's 8 panels and inverters on this side and 8 panels and inverters on the other side. And then there's a combiner that brings together these two branches. The roof racking is from Iron Ridge. And the way that the wiring is going to go is that there's a subpanel in the garage right here, and it's going to backfeed from the garage all the way over here to the main service panel. And the sub panel and the service panel also had to do an upgrade on them. And so we'll get into that once we go over the solar stuff. So this is the site plan. Next up we have the roof plan. So this is just a zoomed in version of the roof. You know, I've got two sides of my roof. This is west and east facing roofs. And yeah, just lay out the dimensions of the roof, and I did a frontal view as well to give you an idea of how high off the ground everything is. Next thing they want is photos. I have a window from the second floor of my house that I can see the roof of my garage. So I took this window from inside of the house, and then this window, or this photo, is just taken from on top of the garage roof. All right, next up is framing details. And so this is the garage roof again, and each one of these black lines, I've specified that that is the roof framing. It's 2x4s that are 24 on center framing. That's pretty standard for roof rafters. The racking is the iron ridge racking, and then specify the grounding wire that runs together and connects all of them. I'm using these boxes called Quick PV Q box for converting the inverter cables into just normal Romex, and we'll see that when we go outside. This is the roof grounding plan, and this is something that I didn't actually come up with. This just came from Iron Ridge when they provided all of their paperwork on the installation. They also had this like general grounding plan. This is basically a complex way of just saying that we don't have to run a grounding wire to every individual panel, because the racking itself is conductive and the frames all are conductive as well on the outside of the solar panels. And so this is just saying that the bolts and the frames are all grounded to each other, and that you only have to have one wire connected to the frame that then goes down to a grounding rod. So you don't have to run a grounding wire to every single panel. You just run the Q cable. That's the special PV cable that runs between solar panels, and then one wire for all of the grounding. You also really only have to ground every other rack, because these two are grounded by the panel, these two are grounded by the panel, so you just need to connect it in two places. This is more framing details. The city of Oakland was very stringent about one funny thing here. They really wanted to know the size of the bolt and how far it was going to go into the framing member. Again, this is not specifications I did. This came from Iron Ridge's own, just like PDFs, and I just inserted them into this overall plan. This is just more details from Iron Ridge. This is how their flashing system works. This is how it all clamps together. This is how you do a splice. All of that stuff. Again, just more copy and paste from PDFs. This is load calculations. So this second page of the worksheet here, where it's asking for the overall total weight, number of attachment points, total weight of the rails, and everything like that. This was done for me by Iron Ridge when I ordered the racking system. I ordered it through wholesalesolar.com. Wholesale Solar then connects you with Iron Ridge, and you can include something like this, that, you know, calculations were done by the manufacturer, by this guy here. Thank you, Ethan, for doing this for me. And then this gives you all of the numbers that then, you know, ultimately they just got copied over here. So that's great. Have an engineering backup saying that your roof isn't going to fall in by putting an additional weight on them. And that's it for what was actually required. This is a wiring diagram that is not actually required for the PV install and wasn't even required for the solar upgrade. But there was something similar that was created for me by Wholesale Solar that I then amended and expanded. And although this wasn't required for my PV install, I actually found it to be really useful as a reference anyway. Just going through, like, that the panels are DC, they get converted to AC, you go through the combiner box, and then just keeping track of what size wire everything was. This just helped me keep all of my calculations straight and all of my materials straight. So not required, but still useful to have. So that's it for the solar paperwork. I'm going to go and do the paperwork for the service upgrade as well. And then once we do that, then I'll actually go out and show you guys the whole setup. All right, now we're going to go over a quick rundown of doing a service upgrade, which is also necessary for my solar installation. This gets a little bit more complicated because you're working with the power company and the city at the same time. PG&E, they're the main energy provider here in Northern California. They have this helpful website. It's listed right here, Customer Connections. If you search for PG&E Customer Connections, you'll get to this useful website that tells you all of the information you need. This PDF here, plus it gives you a portal where you can apply and go through the application and everything. But the process for PG&E gets a little bit confusing in that PG&E has to review all of the designs, but so does the city. And so the way that this works is that you first have to get a permit from the city, which was pretty easy. The city really only required some rough photos of the overall situation. And so I sent these photos to the city, and they issued a permit, even though it wasn't really reviewed in any way. Then you apply for a change to your service on PG&E's website, and you have to insert the permit number that you got from the city in order to start the application. So city permit first with a minimal amount of information, then apply that permit number to PG&E. PG&E contacts you. They did indeed do that. They just asked for some additional photos. In the case of a residential install, I got put into like the express pipeline for like something that's what they consider to be not very complicated. PG&E will prepare project design. I don't think that this is actually going to be necessary because there's really no advanced preparation on their part. And then here's just some additional information about links to what PG&E expects for overhead service, which is what I'm doing, or underground service. Links off to their documentation. They have their really kind of central documentation is this thing called the Green Book. And the Green Book is like a 200-page document about everything you could possibly need for what kind of expectations they have for a power hookup. Then lastly, you'll pay them if they need to do any construction, and then they'll schedule an inspection where the city will come out and inspect the electrical panel prior to them actually installing the meter. So the city will inspect everything prior to the hookup, and then I imagine after this there's no more steps, but PG&E would actually go ahead and install the meter and connect all the wiring. All right, so we'll do one more run through of the service upgrade itself. So this is real similar. This is the site plan that I used for my PV permit. And to be super clear, you need a separate permit, one for the PV install and one for the electrical modification. So there's two separate permits that have been applied here. This is the solar electric number. The general summary here is that we're going to be upgrading from 100 to 200 amps. We're going to be running a new 2-inch mast. This is a weird requirement, and we'll see it when we get into the panel, that the city of Oakland has some of the strictest electrical specifications in the entire country, and they require every single breaker to be one of these arc fault combiner breakers, even in a service upgrade or a panel modification like mine. So even though all of my wiring isn't going to be replaced, I have to replace all of the breakers with these really expensive versions, and it's a big hassle because the wiring cannot be made for it, and we'll get to that later. Running some SCR wire, service entrance wire, through the crawl space. I'm going to be running some used 2 wire through this buried conduit, and then there's going to be the sub panel out in the garage. So the general way things are looking, so this old panel is going to go away, the new panel is going to go right next to it, the old mast is going to go away, the new mast is going to go right next to it. But with all of this plumbing here on the outside of the house, I couldn't fit this 2-inch mast in these holes, and it would bump into that. So what I'm planning on doing is running this mast inside of the wall up until it gets to the top of the house, and then it'll pop out, and then do a little elbow out to where the current mast is. Outside, we have a buried PVC conduit that's 2 inches in diameter that will be used to run the main wires out into the garage. We are going to put a 100 amp solar panel out in the garage, and that's what the solar panels are going to hook up to. So this last part is the wiring diagram. I kind of marked out, this stuff is not relevant because that's from the PV install. The only thing that's relevant for the service upgrade is this portion. And this part here is really key. So part of the National Electric Code, here's the section number. There's a rule called the 120% rule, which is really pretty simple, that if you have power coming in from 2 sides of your panel, so this is a 70 amp breaker that runs out to the garage, and a 200 amp breaker that comes from the city. The rule is that your panel has to be rated, the bus bar inside of it has to be rated for 120% of, I'm sorry, you can feed power into it up to 120% of the main bus bar rating. So this was a 225 amp panel, and that's what its bus bar is rated for. So if you take a look at the numbers there, 225 amps, and say times 1.2, that's 120%, that equals 270 amps. And so 270 amps, that means that the amp that is coming from the garage is a 70 amp breaker, and then I took out the main breaker from the main panel that had been 225, and I downgraded it to 200 amps. And so that makes it so that the bus bar is rated, at 120% to be 270 amps. 70 plus 200, it matches. So this fits within the 120% rule for backfeeding electricity from a sub panel while also getting power from the city. Okay, here we are up on the roof of the garage. This is after everything has been installed, of course. There are 2 panels still missing that are on their way, but this will be useful to demonstrate how things are hooked up. So this system is a microinverter system. This is a microinverter. There is one of these underneath every one of these panels. So there's 2 hookups on it. This side, which is taped off right now, is where the solar panel plugs in, and so that's DC power. The microinverter converts it to AC power, and it runs through these things called Q cables that are real simple. There's just one simple cable, and you daisy chain them together. So this is at the end of the chain, but it runs down through these 3 panels, comes across, and then down, and then it terminates on this side. So they're all just connected all together. one right after the other. And then at the very end of it, we've got it going into this handy thing called a Q box, where it's like a junction box combined with sheathing to make it so that water won't get down into the roof penetration. Inside of here, it's really simple. This is the cable coming from the solar panels, and there's this orange wire here. This is just standard Romex cable that runs down through a roof penetration of like 6 inches of EMT conduit. So that's fine for like protective measures, that it's just a sheath that the Romex runs through, and there's no need to use like separate individual wires in there. This is the main grounding wire, just connected to lugs like this on every other rack, like I said in the paperwork. So it's connected here, and it's connected down at the bottom. And this is 6 gauge copper wire, and then this just runs down to the ground. Alright, here's the underside of my roof. This is one of the roof penetrations. Like I said, it's just some EMT. I think it's 1 inch diameter EMT, and a little cable clasp down at the end, and then the Romex just comes down into the room. One of the great things about microinverter systems is that the power is just alternating current power at this point, so it's no more dangerous than your standard housing wire. That if you were to get electrocuted by it or something like that, the breaker would flip into which this is connected, and then the solar panels automatically shut themselves off when disconnected from an input source of power. So it's really great. So these wires run around. There's the other roof penetration, and sorry, there's a bunch of stuff in my rafters, but these orange wires come down, run down over here, and it gets a little messy down here because this is my shop, and this is the new sub panel, but we'll go into where these orange wires run first. And this is not a complicated box at all. We've got 20 amp breakers, so each string of microinverters. I can't quite remember how many panels you can have. It depends on the output of the panels. I think in my case I could actually have up to 12 panels on each 20 amp breaker, but I've only got 8. But I've got 2 sets, one for each side of the roof. So flipping off this breaker would turn off the east, this would turn off the west side of the house. And then this in-phase box is called the IQ Combiner. And this breaker here just powers the circuit board back here, which is just like the it's the monitoring hardware that then connects to an internet connection and also has Wi-Fi, and that uploads to Enphase's website that then makes it so that I can use an app on my phone to see how much solar panel power is being made every day. So so this is the power from the city, or sorry, power from the solar panels, and this here is just a set of non-metallic wire that runs over to, you can see it right here, this black wire runs into this panel, and this is a 40 amp breaker to match the, the 220 amp breakers that are in the site. So 40 amp maximum of solar panel coming into this sub panel. These wires here, these are the big fat wires that run down the conduit, and then they come out the side of the house. There's a buried conduit, 2-inch conduit that runs along here, and then runs here to this box that then goes underneath the house. There's a junction box under the house that then converts it from those individual wires that you saw in the panel, they're used to, into service wire, so I don't have to run the whole thing in conduit, just this outdoor portion. And I could have actually switched to that service wire here, but I thought it would be just tidier to run the use 2 cable all the way up into the box. Next to it, we've got a new grounding wire. When putting in a subpanel like this, it's required to be separately grounded. So I also have this grounding rod here, which was added. This is a 8-foot long grounding rod driven into the ground. And then all the rest of the wiring in here isn't really relevant to the solar install. It's just this guy that comes from the combiner box and this guy that runs to the main panel. Okay, here we are at the main panel. This is the old panel that is being replaced. It still has the meter on it, and this next to it here is the much larger new panel. So before I get started, I'm gonna turn off the service main here. You might not be able to see it, but there's a 100 amp breaker, and so that's the maximum service we have right now. I'll turn that off and show you what we've got on the inside here. So the inside, all of these breakers are actually no longer connected. There's just the main breaker here that comes in from the meter. And then I have a temporary 40 amp breaker in here that is the only thing that is actually still hooked up. And this 40 amp breaker just has some 8 gauge wire that runs over into this new main panel. And so this is the temporary wire that feeds into this 40 amp breaker. So in reality, even though we have a 100 amp service, at this point everything is running through this 40 amp breaker, and that's fine. We just don't draw a lot of power for the time being, and really with the solar panels, we're actually mostly producing power rather than consuming at this point. But so this is the new panel. This is, like I said, the temporary breaker that is providing all power from the city. The main breaker here, remember at the beginning that this is a 225 amp panel. You can see it here over here in the specifications that that it's rated for 225 amps. Sorry about the focus. I don't know what's up with the camera here. It's rated for 225 amps. And the bus bar rating is also rated for 225 amps. Sorry, that's not going to focus. But I replaced the main breaker with 200 amp breaker instead of 225 amps. And then these big fat wires right here are the ones that come all the way from the garage. And again, they're hooked into a 70 amp breaker. One more rule about the backfeeding like this: if you have power coming from 2 locations, one from the city and then one from your solar installs, the breakers have to be on opposite ends of the panel. So in this case, my main breaker is at the bottom, so I had to put the solar breaker up at the very top. If your box is inverted, it may be the other way around. Main breaker at the top, the solar breaker needs to go at the bottom. These are all of these fancy arc fault breakers that I was talking about. The city of Oakland requires you to use arc fault breakers in all living areas for light fixtures and outlets, even if you're just doing a service upgrade like this. So this was a big pain point for me, in that my existing house was wired in a way in which the neutral wires, the white wires here, were shared between between 2 hots. So this is an example here where I've got a red and a white, and then they were feeding into, or sorry, a red and a black, and they fed into one white neutral. And so there's one wire that powers, I think, like in this case, this is let's see, this is the living room. So the living room outlets and the dining room outlets, living room, dining room, they were run off of one wire, and you have to get these special combiner breakers that combine the 2 circuits so that they flip at the same time, and then the neutral plugs into the breaker as well. So it's a little inconvenient, but you know, we made it work eventually. This box also was advertised as having like this plug-on neutrals where you don't need to have the pigtails on your breakers, but these combiner breakers still have the pigtails. You can see them back in there. So it really wasn't that great of a benefit in the end. Anyway, I'm going off on a tangent. Most people won't need to worry about that anywhere else in the United States. If you're doing a service upgrade, you can continue using just standard breakers, and it's only in new construction that these arc fault breakers are required. Not quite done yet. Oh, this is where all the wires are coming in from underneath the house, and this gray one back in here is the service entrance wire that ultimately comes from the garage. I have a new grounding wire. It runs down and it connects to this existing grounding rod, but doing a 200 amp service, you're required to have less resistance between the power line and the ground, and so that means that for most people the easy solution here is that you drive a second grounding rod. So this is another 8-foot grounding rod that's connected by the same 6-gauge copper wire. So they're both connected there, and you're also required, this is a spigot that runs out, this is the main plumbing line. You also have to ground all of your plumbing in the house. So that gets all of the plumbing grounded and all of the box grounded. These are the main new electrical wires that I've labeled just with electrical tape, that they run up, and this is a recessed panel. There is now a 2-inch rigid pipe that runs up the interior of the house all the way up until you can see all the way up here. It pops out of the interior and becomes exterior and then runs over. And apologies for the sun, but you can see these 3 wires here that are just floating out there. Those are the new wires that will be hooked up to the city, and there's already the old mast runs up, and so the existing power lines connect right in there as well. So I'm not sure if the city will need to run new power lines here, or if they'll just disconnect the old ones and connect it right to the old ones. Could go either way. But that's it for the panel situation outside. Alright, one more thing about the main panel here. We got everything all buttoned up. This is the main panel reading, and it rotates through a couple of different items here. If you're not familiar with reading your own panel, this demonstrates the electrical output or input, depending on if you're coming from the city. So this is the overall kilowatt hours that have been drawn from the city since the meter was installed. This is the wattage that's currently being consumed, but in my case it's actually negative because power is going back into the city rather than being consumed. So that's like the meter running backwards, but the kilowatt hours don't actually go down yet. I'm guessing that might change once I get this approved from PG&E. So there's negative 2.4 kilowatts going back into the city, and then this is the voltage that is going into the system. So it's pretty cool. You can see it's definitely working and putting power back into the grid. And one more thing, in order to get this approved by the city, you have to have a lot of labels. So these labels came from pvlabels.com. A lot of them weren't relevant to the kind of system that I was doing, but a label here for saying, you know, the meter is serviced by a solar install, saying that there's, you know, this is the requirement here, shall not exceed the ampacity of the bus bar. That's that 120% rule that I was talking about. And then just saying that there's solar installed on the inside here. We also have notice saying that there's, you know, dual power supplies present. This warning saying that the solar electric breaker is backfed, and that because this is a I guess called an overcurrent device, I guess it just means breaker, this shouldn't be moved because, like I said, it has to be on the opposite end of the bus bar. So I was just saying don't move that. So that's it. That's the total of the solar install project that I put together. I started this back in April, and it's now August, so I mean, it's took me quite a while to get everything all together, but I've got my inspection scheduled and hopefully everything will pass. So that's it. I hope you found this video helpful. Hi there, I'm Nate Lampton, and I'm going to be showing you guys the paperwork and all of the completed work that's necessary to do a solar installation by a homeowner such as myself. So we'll start going through all of this paperwork.